We're going to do the line integral shown along the curve C given. Before we actually do the calculation, I want to talk a little bit about what this might mean. So, what are we taking the line integral of? Well, we're taking it of a vector field, and the vector field is of the form minus yi plus xj plus cos z k. So it's got minus y in the I direction, x in the j direction, cos z in the k direction. And what's the curve? Well, the curve has I component cos t, j component sin t, and k component t. The I and the j components should make you think of a circle, and as you go round the circle, because the k component is t, it will be increasing. So if we try and draw that, we're going round a circle, and as we go round the circle, we're moving gradually upwards. So what we'll get is a coil. Of course, as t is only going from 0 to pi over 2, it's only a part of the coil. So what does taking this line integral mean? Well, what it means is that if you think of a particle moving along the curve subject to the force given by the vector field, then what we're calculating when we do the integral is the work done by that particle. Okay, well, let's now start by doing the actual integral. Well, in this instance, we've been given the curve in parametric form, and that makes it particularly easy to rewrite the integral as an integral in terms of t. To do that, we need to use the information from the curve C. That is, we've got an x component cos t, a y component sin t, and a z component t. We'll need the derivatives of those, so I'll just work them out. Cos t gives minus sin t gives cos t, and t just gives 1. With this information, we can rewrite our integral as the integral from 0 to pi over 2. The first term, minus y dx, we can now write as minus sin t, that's the y. Dx by dt is also minus sin t, so we'll get minus sin t squared. The next term, we have xt, which is just cos t, and we've got dy by dt, which is also cos t, so we get that squared. And the final term is cos z, and since z is t, that is cos t, and we need to multiply that by z dash t, which is just 1, and so we've rewritten our integral. Now let's simplify what we've got. Well, we've got sine squared t plus cos squared t, which gives us 1, and we've got cos t, and we need to integrate that with respect to t. That's nice and straightforward. 1 integrates to t, cos t integrates to sin t. The limits are 0 and pi over 2. So when I put in the limits, I'm going to get pi over 2 plus 1, since sine of 0 is 0 and sine of pi over 2 is 1. And that is our answer.